In these next questions, we're going to be using the multiplication property, but first we may have to do something else. So for example, in G here, first we want to gather our variables on one side and everything else on the other. So remember our steps. Step one, distribute to remove any brackets. Here we don't have any. Number two, combine any like terms we have on the left or right. Here we don't have any, but we do need to do step three. And that's we're going to gather our variable, in this case n, on the left and everything else on the right. So to do so, I'm going to subtract 2 from both sides. That leaves me with 10n equals 40, and now I'm going to use the multiplication property because I want to know what a single 10 or a single n equals. To do that, I'm going to divide by 10, and I get n equals 4. Go ahead and pause this video and try h. Okay, let's do h together now. So first I want to remove that plus 1. So to do so, I'm going to subtract 1 from both sides. That leaves me with negative 143 equals negative 11x. And now to get just my single x on its own, to isolate that x, in other words, I'm going to divide both sides by negative 11. And if I do that, I get 13. In I, we want to once again isolate our x. To do so, we would divide both sides by negative 15. Okay, our negative 15s cancel on the left. We're left with x equals, and 0 divided by any number is 0. So our answer here is just x equals 0. And finally, let's do j. So first we're going to add 2 to both sides so that we gather our variables on one side and everything else on the other. That leaves me with negative 122 equals 14k. And now what are we going to do? Well, now we know what 14 k's is. We'd really like to get rid of that 14 though, so we know what a single k is. So we're going to divide both sides by 14. And what does that give us? That gives us a fraction. So what's the lowest terms we can put that in? I notice they're both divisible by 2. If I divide by 2, I get 61 over 7. 7 is prime and 61 is not a multiple of it, so that is my lowest terms. All right, moving on to word problems. We have the sum of two consecutive integers is 91. So consecutive means they're right next door to each other. Consecutive numbers would be like 7 and 8 or 17 and 18. So they're one apart from each other. So the lower of those integers, I'm going to call x. So let x equal first integer, I'll say. Well, if x is the first integer, we know the next consecutive integer is going to be one more. So that would be x plus 1. So x plus 1 is going to be our second integer. So we're told the sum of these integers, so the first integer plus the second, equals 91. My first integer, should have used some colors here, but my first integer is x. Okay, so here's x. And then we've got plus. My second integer, I said, was x plus 1. So it's going to be x plus 1. And those two integers together equal 91. Now we have a linear equation we can solve. So we're going to get rid of any brackets as step 1. There are none. Second step, we're going to combine like terms. Here we have two like terms we can combine. So we get 2x plus 1 equals 91. And I'm just going to move this over here so I have enough room. Okay, step 3 is gather our variables on one side and everything else on the other. So to do that, I'm going to subtract 1 from each side. That gives me 2x equals 90. And then step 4, we want to isolate our variable using the multiplication property. So here I'm going to divide both sides by 2, And that gives me an answer of 45. So my first integer then was x, which is 45. And my second integer, I'm just going to write that here, so that's 45. My second integer then would be x plus 1, so 46. So the two integers are 45 and 46. Okay, last word problem. On his first day on the job, Sam processes all the film that's given to him. The following day, his boss gives him 4 times as much film to process. Over the 2 days, he's processed 60 rolls of film. We want to know how much he processed on the first day. So our mystery number we're trying to figure out, I'm going to call that X, is the number of rolls from first day. Okay, we know on the second day, he processed 4 times as much. So on the second day, he processed 4 times whatever X is. So between the first day and the second day, he processed 60 rolls. His first day, he processed X number of rolls. That plus whatever he processed his second day, which was 4 times whatever X is, altogether gives us 60. So this is our linear equation. This is from our first day. This is the amount of film he processed on his second day. And so we're going to first distribute to remove any brackets. Here there are none. Step 2, we want to combine our like terms. Here we have 2 like terms on the left. We can combine those to get 5x. Okay, and now we're going to gather our x's on one side and everything else on the other. That's already been done for us, so step 3 is already done. And step 4, we want to isolate our variable. So to do that, we're going to divide both sides by 5. And that gives us x is 12. So he processed 12 rolls his first day. 12 rolls his first day.